Good morning, class. Welcome from the 3-week holiday. I think it was a bit too long. No? So at this point, we in our last lesson we spoke about functions, no? And determining the equation of a function. At this point, we have completed the equation of a parabola, I think, no? Then you guys had homework, no? That last lesson, for those of you who are in that lesson, you had homework, and the homework was exercise 5.18. You had to complete whatever is in that lesson. Okay. Was there any problems with 5.18? No. Yes. You had a problem. What was the problem? 2D, 3D, 1D, 3D. Any other issues, people? No other issues? So it's only 3D, and this is on page 160. Huh? 161. Is that correct? Okay, so the question says, determine the equation of the parabola in the form of y is equal to ax squared plus bx plus c. Okay. So what we notice here, what is given, got two y-intercepts. Oh, sorry, two x-intercepts. So that follows a formula, y equals a into x minus x1, x minus x2. So x1, x2 are your x-intercepts. So y is equal to a into x minus 3 and x minus 5, or x minus 5 times x minus 3 is the same thing. To solve for a, I must substitute the point this line on this graph, which is 0 and 20. That's remembering that's the x and the y. So 20 is equal to a into 0 minus 3, 0 minus 5, which gives us 15a. Divide by 15 both sides, so a gives us 4 over 3. Right? So we have y is equal to 4 over 3x into x minus 3, x minus 5, which then gives us, now multiply the story in, it's going to give you x squared, so it's 4 over 3x squared. That's going to give us negative 8, so it's negative 32 over 3x. There's going to be positive 15, and you positive 20. So where did you go wrong? Okay, then what answer the textbook have? Exercise 5.18. Yeah, the textbook is wrong. No, they got 4x squared minus 24x plus 20. Yeah, it's wrong. Okay. At this point in our lives, you're correcting the textbook already. Nice. Nice. Alright, so now we're going to look at determining the equation of the hyperbola. Okay. So that's your new heading, determining the equation of the hyperbola. Which topic are you self-studying at this point? We have completed stats, no? You're busy with probability. Did I give you probability to complete over the holiday? No, okay. How far did you get with probability? The first lesson. Right, so you move on to the second lesson. Okay, that should be done by Friday. Okay? We got the second lesson to be done by Friday. Okay. Lesson 2. Probability for Friday. Okay. We're going to finish probability this term. Okay. Determine the equation of the hyperbola. We're reading from page 161. Example on page 161. Okay, so we are told determine the equation of the hyperbola. In general, the equation of the hyperbola is in the form of y equals a over x plus p plus q. Sometimes they have it as y equals a over x minus p plus q. Let's make a note of that. Can be written in either or. Okay. Determine the equation of the asymptotes, hence determine the value of p and q. Then is to substitute the coordinates of point on the graph into the equation y is equal to a into x plus p plus q to determine the value. Okay, so make that note quickly. Okay. So the example on page 161. We are told determine the equation of the following hyperbola where the general equation of y is equal to a over x plus p plus q. The vertical asymptote is x equal to 2. The asymptote stands up straight. This here is x equal to 2. Can you see that? And the horizontal asymptote is y is equal to 1. The graph is passing through 4 and 3. Okay. So where do we start? We start by writing down. The equation of the hyperbola, the general equation, which is y is equal to a over x minus p plus q. If you write plus, is no problem. This is a habit of mine, and the way I set it in the exam, I wish to say minus. Okay, but if there's a plus, there's the same. Okay. So the first thing is we know that q represents the horizontal asymptote, not so. Whilst p is the vertical asymptote. Are you all okay with that? So what is your q value? It's 1. Not so? And what is your p value? It's 2. Not so? Right. So if you write that in, you fill that information in, you got y is equal to a over x minus 2 plus 1. And there you can see x minus 2. What is your asymptote value here? X is equal to 2, not so. And that can confirm that. Remember, the x is always the additive inverse. Okay. So what else do you need to solve here? You need to solve a, which is one unknown, not so. So how are you going to solve for a? To substitute the point that's lying on this graph, which is? There we go. So we're going to substitute 4 and 3 into that equation there. Do the substitution, you solve for a from equilibrium. X and a y, so what do we have? 3 equals a over 4 minus 2 plus 1. Not so? Take it 1 over, becomes negative 1, so it's going to be 3 minus 1, which is 2, equals a over 4 minus 2 is cross multiply, so a is equal to. Have I answered the question? No. Therefore, y is equal to 4 over x minus 2 plus 1. Okay. Any confusion here? No? Right, let's look at another one. Have we completed 3 graphs? Okay, once we're done with functions, and we'll just wrap up. I think the last part of 3 graphs and the general solution in chapter 7, we must still wrap that up as well. No? Right, so this is example 2. On which page is this? 162. Example 2 on page 162. So here we are told that determine the equation of the following hyperbola where the general solution is y is equal to a over x plus b plus q. Right, so what do we notice here? What is your q value here? Q is your horizontal asymptote, not so? What is the equation of the horizontal asymptote? 0. So y is equal to 0. So what's your q value? 0. Not so? P is your vertical asymptote, not so? And this equation of this vertical asymptote is x equal to minus 1. So what will go under this equation here? X is equal to positive 1. Not so? So in that case, I just need to solve for a still. Not so? Do I have a point on this graph? Yes, yes. Who's talking? Yes? You got, if the denominator is a over x minus 1, without looking at that graph, we know the asymptote of that is x is equal to 1. Not always an x, no? But importantly, it's always the additive inverse. So if this is x minus 1, it's x equals 1. Can you see that? So since that is negative, this must be positive. Okay. So in the pursuit of calculating A, I'm going to substitute a point that's lying on this graph, which is this point here. I'm going to use 0 and minus 3. Or I could have used this point here, which is minus 2 and 4. I could have seen that that point is also on that grid there. Can you see that, people? But I think that is a better. Or we will all use the same one. So you can use 0 and minus 3. Okay. So if you make a mistake, we can pick up. Okay. So determine the equation of that hyperbola quickly. Okay, so what happens here? Y equals A into x minus p plus q, or y is equal to A over x plus p plus q, the same. No? So what we say, your q value is 0 and your p value is 1. Or if you got a plus 1 here, then here will be a minus here. Not so? Right. So you got the equation y is equal to A over x minus 1. There's actually minus here. That will be a plus. Okay. Y is equal to A over x plus 1 plus 0. Not so. But I don't need the 0 here. So at this point, we just still need to solve for A. So let's substitute the point that's lying on this graph, which is 0 and negative 3. And remembering that's the x and the y. So negative 3 is equal to A over 0 plus 1. That's going to give us 1 there. So A is equal to negative 3. So what's my equation? Y is equal to negative 3 over x plus 1 plus 0, which is that thing. Okay? Who got that right? Where did you go wrong? You got it right. Now why do you put up your hand? You're better than us. No. You don't want to play along. Hey, Cheryl? What's your name? What's it called? It was close, no? No, who's Cheryl? Wow! I felt so confident today. Right, listen. So, we're going to go now into the equation of the exponential function. Okay? Determining the equation of the exponential function. It's a little note I want you guys to write down quickly. Determine the equation of the exponential function. In general, the equation of the exponential function is in the form of y equals 8 times b to the x plus p plus q, where b is greater than 0, which means to say b is positive. However, okay, and importantly here, b can never be equal to 1. No? B won't be equal to 1. I think you must just add that there. B will never be equal to 1. However, You are seldom required to find the values of all four of the unknowns, A, B, C, and A, B, P, and Q. So very seldom will they ask you to work out all four. Okay. At most, you will require to find 2 out of the 3 of the 4 variables. 2 or 3, or 3 in this case, 3 out of the 4 variables. The others will be given. Okay. The method determines the equation of asymptotes and hence the value of Q. So we know that the exponential graph has one asymptote. Not so? Which is the horizontal asymptote, which will see your Q value. Substitute the coordinates of 2 points of the graph into the equation in order to determine the value of the values of the remaining unknowns. Note that it will sometimes be necessary to use the coordinates of only 1 point. It depends what is required. Not so. Once you got Q and there was 2 unknowns, of course we need 2 points. Why? Because that will then go into simultaneous equations. But if it's 1 point, if it's still 1 unknown in that equation, then if it's 1 unknown in that equation, we just need 1 point. Okay. And if the question is for exponential function, and you need to determine the equation thereof, they will give it to you in the form. Okay. Where one of the values are known to us. Either P or Q or whatever. Okay. So you can make that note there. I'm going to freeze the screen. Guys, finish? Another minute. Okay, so we're looking now at example 1 on page 163. Example 1 on page 163. We are told, determine the equation of the graph y is equal to a to the exponent x plus q, where b is greater than 0, but b can't be equal to 1. Eh? So what is your a value here? Remember there was an a in the previous question. Sorry, not in the question, in the summary. Or in the introduction, sorry. What is your a value here? 1. Not so. So the a value is given. So you don't need to solve that. Whose horizontal asymptote is y is equal to negative 4. So what value is the negative 4? The q value. So at this point my equation now reads y equals b to the exponent x plus q. The q value is negative 4. So y equals b to the x minus 4. And which passes through the point 2 and 5. So would I use 0 and minus 3? Would I use that in my calculation? No. Why? Because at this point was given to us. Can you guys see that? It probably wouldn't be wrong to use that. But just to play it safe, you work with what is given to us. You guys understand? So at this point we're going to substitute. And to substitute which point? 2 and 5. Remembering that's an x and a y. So do the substitution and solve for b. Okay, so what do we have? 5 equals b to the exponent 2 minus 4. Not so? To get over the equal sign. So b squared is equal to 9. Square root, what must I not forget? Plus or minus. So b is equal to 3. Why? So b must be greater than 0. Not so? B has to be positive. As you can see, the condition is given. So therefore, y is equal to 3 to the x plus, sorry, minus. You all agree with that? You all okay with that, people? Any confusion? No? Carry on with the lives. Example 2 on page 163. Determine the equation of the graph. If the equation is of the form y is equal to a times b to the x. How many unknowns are here? 2 unknowns. Not so? So how many points do I need? 2 points. What's your value of q here? 0. Not so? What's your value of p here? Where does p fit in? P is here. You see that? Plus p here. So what is your p value here in this equation? Also 0. There's no p. Not so? So it's 0. You guys understand? So the horizontal asymptote, which is y is equal to 0 here, is that 0 there. Not so? Right, so how am I going to solve the value of A and B? We're going to substitute, yes? One of the points, the given points. Which point is given? 0 and 3, and this point here? Negative 1 and? How do I know it's given? So I like this. Not so? Which one do I start with? 0 and the 3. Why? Because this might eliminate one of the variables. I always substitute what's on the axis first. But if you go and substitute the other way around first, it doesn't matter. Okay, it's still going to be the same answer. Okay? So I'm going to substitute 0 and 3 into y equals a times b to the exponent. So do that substitution, remembering that's a x and a 1. Okay, so if we do the substitution, we now have 3 is equal to a times b to the exponent 0. Anything to the power of 0 is 1. So a is equal to 3. What did you get? 2? You got 3. Now I got you.
No, I said 1. I said
A is equal to 1?
No, it was a mistake.
No mistake. Okay. So my equation now reads y is equal to 3 times b to the x. Not so? So what do I do now? Now we're going to substitute negative 1 and 6 into y equals 3 times b to the x. Remembering this is an x and a 1. Not so? Yes, Michael? Yes? The same formula as y is equal to this one here?
No, so I'm asking why can't you substitute the same point as, why can't you use directly again?
You can only use a point once. So if I'm going to substitute 0 and 3 again, let's see what we get. So if you got y is equal to 3 times b to the x, you substitute 0 and 3. So you got 3 is equal to 3 times b to the 0. 3 is equal to 3. So it's not going to help us. Not so. And remember, we used the point once in this format only. Okay. Later on you'll see grade 12, we can use a point twice. And the turning point is given. Okay. But for now, use a point once. Okay. So what do we have? 6 is equal to 3 times b to the negative 1. So what do I do now? Divide by 3 both sides. So b to the negative 1 is the same as 1 over b is equal to 2. And that's naturally 2 over 1. You cross multiply. Or I can take the reciprocal of either side. You take the reciprocal of both sides. It's a fraction on either side of the equal sign. We can take the reciprocal, so b is equal to a half. Not so? B is equal to half. Or if you cross multiply 2b is equal to 1, divide by 2, b is off. Are you all okay with that? So what's my equation? Therefore, y is equal to 3 times half to the exponent. Okay. Any confusion? No? Let's go to example 3. Example 3, and this is on page 64. Just write the reference down. Example 3 on page 164. The question says, determine the equation of the following graph in the if the equation is in the form of y is equal to b to the x plus p plus q. Alright, we are given the graph there. The graph is going through 2 points, 0 and negative 1, and 1 and 1. Now what we notice, we have a horizontal asymptote at y is equal to negative. The negative 3, sorry. So what can we determine at this point already? Your q value. Your q value is? So do you think quickly? So then you write down the equation as it stands at this point. Okay, so what's my equation? Y equals b to the x plus p minus 3. At this point, we're going to substitute the point that's lying on this graph. Not so. So we can substitute 0 and negative 1. Remembering this is the x and the 1. So negative 1 is equal to b to the 0 plus p minus 3. They get over the equal sign, so minus 1 plus 3 is 2. So it's b to the p. Not so? So, if 2 is written on its own, what's the exponent? 1. So therefore, b is equal to? What's b equal to? 2. And what is p equal to? 1. So my equation reads, I don't even need that point. Y equals b to the x plus 1 minus 2. P is 2. So it's going to be 2 to the x plus 1 minus 3. And I can check if I'm correct. I can substitute the 1 in here. Okay, if I substitute the x being 1 in here, I must get the corresponding y value to be 1. So that's going to be 2 to the 1 plus 1 minus 3. So that is going to be 2 squared, which is 4. 4 minus 3 is 1, which makes this correct. Okay? Yeah, we didn't need to use that. Right? Any confusion, people? No? So that basically brings us to the end of that example. So your homework is exercise. The remaining sums of exercise 5.19. However, in this lesson, we're going to answer number 1 of 5.19 and then number 5. Number 1 and number 5. Okay? So I'm going to give you a form 5 minutes to complete those two sums. Then I'm going to answer it on the board. Okay? Exercise 5.19, number 1 and 5. Which page is this on? 164. I take it you guys are done with the first one? Yes, okay. So let's go with the first one quickly. What do you notice? We have horizontal asymptote here, which means to say your Q value is 0. Which is already sorted already at this point. Sorry. So what do I do now? You can substitute. Which point of the two I'm going to start off with? 0 and negative 2 into f of x equals a times b to the x. Remembering this is the x and a y. Not so. So you got negative 2 is equal to a times b to the 0. Anything to the power 0 is 1. So a is equal to minus 2. You all agree with that? So my equation now reads f of x equals negative 2 times b to the x. So now I can use the other point. I'm going to substitute 1 and minus 6 into f of x equals negative 2 times b to the x. You don't have to write this what I'm underlining. Okay? Remembering this is x and a y. So negative 6 is equal to negative 2 times b to the 1. How do I get b on its own? Divide by negative 2 both sides. So b works out to be 3. As you can see, b is greater than 0. Therefore my equation is f of x equals negative 2 times 3 to the x. Would this give us negative 6x to the 0? Negative 6x to the x? Negative 6 to the x. Sorry. Would that be f of x equal to negative 6 to the exponent x? No. Why? Because of that variable exponent on that base. That's why I can't multiply those numbers there. So the answer is f of x equals negative 2 times 3 to the exponent x. Does it make sense? Anybody that's confused? Okay? Give you another 2 minutes to sort this one out, or you guys finish? Finish? Who's finished? Okay, I'll give you guys, most of you are finished. I'll give the rest of you another 2 minutes to sort this one out, okay? What type of graph is this? It's exponential, no? It looks like exponential, but it's not. Exponential got how many asymptotes? 1. This has 2 asymptotes. That's perfect. But what do you notice? The other, what's the name, is not reflected there. Which means to say, this part of the graph is used only. Can you see that, people? But I'll speak about that, more about that once I do the equation, okay? But your horizontal asymptote is known and your y-intercept, and I've got another point in this one. Okay, that's why I chose this one, so that you can go through it together. Okay. So we established that these are perpendicular, and can also note that from the information given. Y is equal to A over x plus p plus q. We know that it will have a vertical asymptote here of 2, which we actually know that the p value is. Not so. So the equation is y equals A over x minus 2 plus q. So how many unknowns are there now? Huh? How many unknowns are there that we need to solve? 2. The a and the q. The x and the y forms the formula for the function. Not so. So we'll substitute. What are we going to substitute? 0 and 5 into y equals a over x minus 2 plus q. Again, you don't have to write that down. Remembering that's an x and a 1. So we have 5 is equal to a over 0 minus 2 plus q. Take it over, becomes 5 minus q equals a over negative 2. Okay? Any confusion at this point? No? So what do we do now? Cross multiply. So 5 times negative 2 is negative 10 plus 2q is equal to a. That's equation 1. You see that, people? So what do we do now? Now you substitute 1 and 7 into, now it must go into this equation again. Why? Because we don't have the value. We didn't solve a over q. Into y is equal to a over x minus 2 plus q. if we have solved A or Q at this point here, then we would have substituted into the new information formula. Remembering this is an X and a Y, not so? So we have 7 equals A over 1 minus 3. Now minus 2 plus Q. Okay? That's going to give you minus 1. So A over minus 1 equals 7 minus Q. So A is equal to Q minus 7. And this is equation 2. So what do you notice here? We've got 2 equations. Both cases we have A as a subject of the formula. Not so? So I can equate the 2 equations. So now we set equation 1 equals the equation 2. Okay. So we have minus 10 plus 2Q equals Q minus 7. Solve for Q. So Q is equal to 3. Okay. So what do we do with that? We sub that into equation 2 or equation 1. So A is equal to 3 minus 7, which is negative 4. So my equation now reads, therefore, there's the equation A. So Y equals negative 4 over X minus 2 plus 3. So if we go back to the equation, this is the sum here. Does this look like a 3 here? Can it be 3? Yes, any value less than 5 it will be acceptable. Can you see that, people? You see this line quadrant 2 and quadrant 4, which means to say it must be positive and negative. Negative, yes, and there's a negative. Now coming back to the sum here, if this was the equation, it should have been reflected here as well. Not so? However, it's only this part of the equation that is drawn. Not so? So in other words, Y must be, sorry, X must be less than or equal to 2. X must be less than or equal to 2 to consider the same. Okay? You guys understand? And for homework is the remainder of that exercise. People enjoy the rest of your day. Good morning, class. Bye. Bye.